All right, let's do a little tour of BLAST and some of the key features. We'll make this quick. Here's the page. Here's some things you can change. Max target sequences. Do 250. Word size. This is a word search. This is how BLAST works. So if you're having trouble matching things, sometimes making the word size smaller will make things match. And there's all this other stuff that you can change. It's more advanced. I really don't recommend messing with it too much. This one is fine. But only if you're finding no results or no close results. It's giving you poor query coverage. You can't seem to figure out what genus or what family it's in. That's when you can start playing with this stuff. And there's little explanations of what each of these fields does. Although I think this is probably going to be the best one, and then you can also remove the low complexity regions. So normally it masks them. So if there's something that's like a repeating region, it wouldn't use it in the comparison. Sometimes there's some repeating regions in the sequence, and it'll filter them out unless you uncheck that. But 99.5% of the time, you're not going to worry about any of that. Good to show results in a new window. And let's just try it here. Not changing any of the other settings other than the max number of target sequences. So you can see it opened it in a new tab, and it's going to take some time. And here we go. It gives us a result. Perenniporia, species California 01. Congratulations. Okay. Well, let's say I want to compare it against a specific organism. Like I think that maybe it's, um, maybe it's actually Perenniporia subtephropora, and I just want to compare it against sequences of Perenniporia subtephropora. We can actually go and choose that. Subtephropora. So now I'm going to compare this sequence against only sequences with that ID. And that way, if there's stuff that's not showing up in the BLAST search because it's so far away, but it's using a similar name, you can find that. And so here we go, and here's actually an example of that. So the first thing that comes up is the subtephropora from type material. This is a type sequence. So ours is a 96% match. It's obviously not that. But if you look at the spread of different genotypes, go all the way down to 89.45% of people using this name. So, if you wanted to compare against this wouldn't even show up in your top 250 BLAST results. So if you want to just see, how many different genotypes are using the same name, this is a great way to do it, especially with like polypores. A lot of them are super messy. Ganoderma lucidum is a famous example where there's a huge spread of different genotypes that use the name Ganoderma lucidum. So that's one strategy you can use. And then I'll do one more thing here. Let's say I just wanted to compare against type sequences. You can click that. And so this isn't going to be perfect. You won't always have a type sequence annotated as a type sequence, but this will compare against all the ones that are annotated. So just because it doesn't show up doesn't mean that there isn't a type. And here it just compared against one. Just because it doesn't show up doesn't mean that there isn't a type. It just means that it may not be annotated as a type. Here, if I remove this, then we'll get a bunch more records. So this is a really important tool, especially because you can choose to search against as many or as few organisms as you want. So here we go. Now it's comparing against all these different type sequences. There's other features. You can always save these results. You can save the search, and then you can download it if you want. There's that's not what I wanted. There's somewhere you can download oh, here we go. Download the results as an XML file or as any one of these. Super useful if you want to save these results for viewing in the future. Graphic summary. This is pretty cool. So this allows you to see a sort of top-down view of query coverage. So this is how all of the sequences that you blasted against compare with your sequence as far as the coverage. So here's your sequence, starts at 1, goes out to here, and here's where each of those other sequences align. How much of their sequence is covers your sequence, query coverage. Okay, so that's super useful. The alignment page. There's also a distance tree. This is almost too annoying to actually navigate. And I don't know if anybody actually uses this, so I wouldn't trust it. It's not really a phylogenetic tree, so maybe ignore that. Yeah, there's a bunch of other sort of things you can do. Let's say you want to compare more than one sequence, you can go here and align 2 or more sequences. So you can copy another sequence in there. Oh, I don't know. See if I can find a sequence kicking around somewhere. So I can compare 2 sequences. And then you can also upload a FASTA file. So if you have numerous sequences, you can upload and compare numerous sequences. Here we go. That's a comparison. There's 2 ranges. So range 1 is the beginning, and then at this point, they don't align at all, really. This is ITS 1 would be here. Then they align again. This is the 5.8S region, which is well conserved. And then here is ITS 2. They barely aligned. They align better than I was expecting for these 2 genera. And then here's the large subunit, beginning of the large subunit. This up here is the end of the small subunit. Also where the primers are. Here's our primer. CTG, GG, CATA, blah, blah, blah. Okay, cool. Well, that's it.